Welcome to my channel, and welcome to this tutorial on calculus. This series focuses on meaning rather than shortcuts, building intuition calmly and carefully. We'll start with concepts that are used throughout calculus, even if they don't formally belong to it. And the first one is exponentiation. Ready? Let's start this adventure together. This is the base, and this is the exponent, also called power or indice. The exponent represents how many times the base is multiplied by itself. Take, for example, this case. The base 2 is multiplied 3 times, which gives 8 as the result. This is a simple example, but what if the exponent is 100? It's better to write this way than the other, right? Now, let's go back to our first example. The exponent isn't always positive. It can be negative or even 0. But what does this mean? Think about this. What is the opposite of adding? Subtracting. And multiplying? Dividing. Therefore, a negative exponent means we should divide the base all these times. Or, if you prefer, calculate the inverse of its positive counterpart. In this case, 1/8, which is 0.125. Let's consider the first powers of base 5 and calculate the results. Look at this pattern. The next result is the previous times the base. This makes sense because you are multiplying a new base each time you calculate a higher power. However, we're missing an exponent, 0, which is equal to 1. And why? Because if you multiply this result with 5, it gives the next result. And thus, the pattern isn't broken. And what about the negative powers? Well, there is a pattern as expected, but in this case is 1/5. The next result is the previous times the inverse of the base. And, once again, we're missing the exponent 0, which, multiplied by 1/5, will give us the next result. As you can see, when the power is positive, the results become 5 times larger as the exponent increases. And when the power is negative, then the results are 5 times smaller when decreasing. And what is the common power? 0, whose result is always 1 no matter the base. Another special exponent is 1, and the result is always the same as the base. The exponent can also be a fraction. In fact, it can be any number. For now, let's focus on fractions. But first, let me introduce the following property, the multiplication rule. Take this example and calculate each power individually. 4 raised to power 2 is 4 times 4. 4 raised to power 3 is 4 times 4 times 4. Which will give a total of 5 bases multiplied by themselves. Now, let's calculate using the other way. In this case, we sum the powers. 2 plus 3 gives 5, which means 5 bases multiplied by themselves. These two terms are equal, thus proving the multiplication rule. So remember, when multiplying the same base raised to different powers, you can add these powers. Back to the fractions. 1/2 plus 1/2 is 2/2, which is 1. Therefore, we get the same value as the base. Can you guess what kind of number, when multiplied by itself, gives its base? That's right, the square root. Square root of 4 is 2. 2 times 2 is 4. As you can see, these two equations gave the same result, which means that these two sides are equal, or better yet, these two terms are equal. Therefore, we can conclude that 4 raised to power 1/2 is the square root of 4. More precisely, an exponent of 1/2 is a square root, no matter the base. Check these simple examples, and try others by yourself. Guess more. An exponent of 1/3 is a cube root. An exponent of 1/4 is a fourth root, and so on. In short, an exponent of 1/n is an nth root. What about a fractional exponent like this one? For that, let me introduce another rule. The power of a power rule. Consider this example. 2 times 3 is 6. Therefore, we obtain base 2 multiplied 6 times by itself, which will give the result 64. Now, try the other way. In this case, first you must solve what is in parentheses. 2 raised to power 2 is 4. 4 raised to power 3 is 4 times 4 times 4, which gives the result 64, thus proving that these two terms are equal. This rule also works when we want to divide the powers instead of multiplying them. In this case, let's consider the denominator as the inverse of n, and multiply it by the numerator, m. We can do this in two ways. In the first, we apply this rule by isolating x to the m, raised to the inverse of n. As we have seen, 1 over n is the square root. So let's apply to our equation. Look at our fractional exponent. Separate the numerator from the denominator. Apply the rule of the power raised to the power, and then the rule of the nth rule, which, in this case, is the square root. 4 raised to the power 3 is 4 times 4 times 4, which is 64. The square root of 64 is 8. The other way is to consider the nth root and raise it to the power m. The square root of 4 is 2. 2 raised to the power 3 is 2 times 2 times 2, which is, again, 8. You get the same result both ways. So, it's up to you. Do you still remember this rule? Take a close attention. This is a special case when m is 1. So far, we have seen the following rules. 0 exponent rule, 1 exponent rule, the negative exponent rule, the product rule, the power of a power rule, the fractional exponent rule, and the square root rule, which is a special case of the previous one when m is 1. Now, let's see more rules, starting with the quotient rule. This is also a special case of another rule, the product rule. Instead of dividing the two exponents, we can multiply the first with the inverse of the second, which, according to the negative exponent rule, is a negative exponent. Therefore, we are adding a positive power with a negative, which will give a subtraction. Let's see an example. 2 raised to 3 is 2 times 2 times 2. 2 raised to 2 is 2 times 2. Two terms in the dividend are removed by the two terms in the divisor, leaving only 2 as the result. If we apply the quotient rule, then we are subtracting the two powers. In this case, 3 minus 2, which is 1. 2 raised to 1 is 2. So, we have the same result. We have seen what happens when we multiply equal bases with different powers. Now let's see when multiplying different bases with equal powers. In this case, we raise the multiplication to this power. Like in this example, 2 times 3 is 6. 6 raised to 2 is 6 times 6, which is 36. Doing in the other way, 2 raised to 2 is 2 times 2, which is 4. 3 raised to 2 is 3 times 3, which is 9. 4 times 9 is 36. By the way, this rule is called the power of a product rule. The last rule is the power of a quotient rule, which, as you can imagine, is a special case of the last one, if you consider the multiplication of the first base by the inverse of the second. Once again, let's see an example. 6 divided by 3 is 2. 2 raised to 2 is 2 times 2, which is 4. 6 raised to 2 is 6 times 6, which is 36. 3 raised to 2 is 3 times 3, which is 9. 36 divided by 9 is 4. These rules will help you simplify equations, as you will see in my future videos. That's why it's important you understand them. If you've learned something new today, don't forget to like the video and subscribe. I'll see you in the next lesson.